Welcome to another tutorial video regarding AB structures engineering. This time, I will be showing you how to solve for the quantity of cement in bags, sand and gravel in cubic meters for a proposed concrete parking area using the area method. I will be solving this problem to show you how it is done. By the area method, determine the quantity of cement, sand and gravel of the proposed concrete parking area 6 inches thick with a general dimension of 50 by 120 meters using 50 kilograms cement and Class A mixture. But before that, don't forget to like, subscribe, and click the notification bell to support my channel grow. In area method, the quantity of cement, sand and gravel per square meter are easily determined depending upon the required thickness of the slab. In our given problem, we have the thickness of 6 inches. However, we have to convert it to centimeters using the conversion factor. 1 inch is equal to 2.54 centimeters. We simply convert and we have a thickness of 15.24 centimeters. Now, we have a table necessary for determining the quantity of our cement, sand and gravel. The table flashed in your screen is from Max Fajardo's book named Estimate. Our thickness is 15.24 centimeters. However, if you see it in the table, we don't have exact values for it. Now, to solve for the materials using this thickness, we apply the concept of interpolation. We have to locate 15.24. Its location is between 15 centimeters and 17.5 centimeters. Through interpolation we can now solve for the values of our cement, sand and gravel. We always use interpolation method if the thickness given in the problem is found between any of the slab thickness in the table. Now, the problem requires us to use type A mixture under 50 kilograms. So, our cement value for the 15.24 can be found from 1.050 to 1.225. Also, the sand value is from 0.750 to 0.0880. The gravel value can be found from 0.150 to 0.175. I will show you how we use the principle of interpolation to obtain the value for the cement, sand and gravel. We begin with getting the cement value. By interpolation, we refer to our table for our values. The left row is the thickness value. We have the 15 centimeters to be the x1, the 15.24 to be the x value, and the 17.5 centimeters to be the x2. Now, the right row serves as our cement value. We have the 1.05 kilograms as our y1, the y value, which is the cement value that we are going to solve using the interpolation method. And, we have the 1.225 kilograms to be the y2. Further, to apply the concept of interpolation, we have x minus x1, all over y minus y1, is equal to x2 minus x1, all over y2 minus y1. We derive the equation to obtain only the formula for our y. Remember that our y is the value for our cement. We derive and we have y is equal to y1 added to x minus x1 multiplied to y2 minus y1 all over x2 minus x1. Substituting values, we have y is equal to 1.05 added to 15.24 minus 15, multiplied to 1.225 minus 1.05 all over 17.5 minus 15. We simply solve and we have the value for y, or our cement value to be 1.0668 kilograms. That is now the solution to our cement value. Next, let us solve for the value of our sand value. Again, we apply the concept of interpolation to solve for its value. We have the 15 centimeters to be the x1, the 15.24 to be the x value, and the 17.5 centimeters to be the x2. Now, the right row serves as our sand value. We have the 0.0750 cubic meters as our y1, the y value, which is the sand value that we are going to solve using the interpolation method. And, we have the 0.0880 cubic meters to be the y2. Now, We substitute values and we have y is equal to 0.0750 added to 15.24 minus 15, multiplied to 0.0880 minus 0.0750 all over 17.5 minus 15. We simply solve and we have the value for y, or our sand value, to be 0.0762 cubic meters. That is now the solution to our sand value. Next, we proceed solving for our gravel value. Again, we apply the concept of interpolation to solve for its value. We have the 15 centimeters to be the x1, the 15.24 centimeters to be the x value, and the 17.5 centimeters to be the x2. The right row serves as our gravel value. We have the 0.150 cubic meters as our y1, the y value, which is the gravel value that we are going to solve using the interpolation method. And we have the 0.175 cubic meters to be the y2. We substitute values and we have y is equal to 0.150 added to 15.24 minus 15, multiplied to 0.175 minus 0.150 all over 17.5 minus 15. We simply solve and we have the value for y, or our gravel value, to be 0.1524 cubic meters. That is now the solution to our gravel value. After solving the necessary values for our materials, we now proceed in solving the right quantity for the cement, sand and gravel. The problem requires us to use the area method. The first step we have to do is to solve for the pavement area. To solve for the area, we multiply the width and the length. I have other tutorial videos regarding this method, simply visit my channel to watch more of it. Substituting the values, we have area is equal to the width of 120 meters times the length of 50 meters, giving us an area of 6,000 square meters. After solving for our area, we multiply this to the corresponding values for our cement, sand and gravel that we solved a while ago using the interpolation method. We begin solving the cement. We have the area of 6,000 times the cement value of 1.0668. Giving us the cement value of 6,400.8 bags, or we say 6,401 bags. Next, the sand. We have the area of 6,000 times the sand value of 0.0762. Giving us the sand quantity of 457.2 cubic meters. Next, the gravel value. We have the area of 6,000 times the gravel value of 0.1524. Giving us the quantity for our gravel to be 914.4 cubic meters. That is now the solution to our problem. Don't forget to like, subscribe and click the notification bell before you exit.